Yeah, thank you for everyone, especially thank you, Professor Saran, for organizing this and inviting me to this wonderful meetup. So I actually want to share the experience we had in organizing the machine learning project in McKenna-Rocks, especially liaison between the data scientists and the software engineers who are in charge of the operation of machine learning system. So the title of my talk will be machine learning operations, or MLOps, for data scientists. Okay. So just want to say that there's the model, the size of the model. You can say that the number of parameters in the model is exponentially increasing, and such a big model plays a very unique and unique roles in machine learning space, right? So this is alpha code from Google DeepMind. So you just specify the problem, and then the model will give the program, right? Program to solve that problem. So this kind of advance was enabled by advance of the big models, right? Very big models. But if you think about the manufacturing, which I'm working on, which I'm focusing on right now, is that. If you take a look at the adoption of the manufacturing, it's very good environment, right? Because usually there are lots of data around, because usually they collect the data from the machines and facilities, equipment, right? And then there's no concerns of privacy or anything like that. So it's actually a really good environment to adapt, to apply the machine learning to get whatever it is for one thing to predict the malfunction of the equipment, or the optimizations increasing yield, right? So the AI ops and MLOps is, as far as I know, is that the AI ops usually means to applying the artificial intelligence to improve the current operations. That's what I usually know. And MLOps usually refers to the system that to efficiently operate the ML and deploy the machine learning models, right? So yeah, I think there's the subtle difference. But for the modelers and data scientists, usually the MLOps will be more relevant. Hopefully I answered the question. Okay, so adoption is very low. So what is it, right? So Professor Andrew Ng said actually he also runs a startup in manufacturing space, and his point was something. His point actually made a movement, something called the data-driven AI, right? The things like that, they usually in the consumer software internet, you can think about search recommendation system, something like that, translation or something like that. Then we could train a small number of machine learning models, right? Then it's usually a very general purpose, and it can serve billion users, right? But in manufacturing, usually you need a lot of models, which means that if the problems at hand is basically the same, let's think about something you need to come up with a model that actually detect a defect in a product, right? For example, let's say, okay, I need to make a model that I need to spot a defect in this piston, right? And you might want to come up with a model that actually you can find a defect in a cell phone screen, right? in a high level, they are exactly the same problem. But if you think about like creating a model, actual model, then it gets very, very different, right? At the like machine learning model level, those two problems are just different problems. So you need to come up with like really lots of models for lots of manufacturing equipment and lots of manufacturers, right? So so usually like they has like usually like consumer AI has like general purpose. Industry specific AI is like the some like a domain specific applications. And consumer AI has actually the problems haven't changed. If you think about like the web page search, even if like the technology behind the search got improved tremendously, right? But the problems that haven't changed since its first introduction. For example, you just type some string, which is an input, and the model is supposed to give you the list of the web page, right? It just doesn't change. But so you have like a lots of millions of user data collected already. But industrial AI is like, as I said, like data collection system are usually well equipped. But if you like introduce a new machine, even if the role of the machine is let's think about some machine, right? And you change the machine with the same machine, for example, or you just like buy another machine to expand your business in manufacturing. On the high level, again, they are the same machine, but depending on the operation mode or the environment, the distribution or characteristic of the data collected are completely different. Sure. Any? Yeah. So, sorry. Yeah. So usually, like if you focus on a single machine learning problem, usually data is not really abundant. It could, yeah. So we suffer from insufficient data problem. And another important point is usually like consumer AI has a lot of like good talents in AI, but usually in the industrial AI, if you can think about like some factories, right? And usually like the AI expertise in this space is like very scarce, if I say. And so one thing I would like to mention is that because we need to tackle lots of problems, I would say that okay, so the model creation and model development in very early stage of the model development, like compared to like improving current existing model, is very important. And data scientists in McCarracks tends to face like the problem of like setting up the environment, development environment, and how to connect the result of their their machine learning model, how to connect their machine learning model to the deployment. So the data scientists in McCarracks tend to face those development, deployment problems more often. And one thing I would like to mention is there's like this called like void law of iteration, which means this comes out during the Second World War, which states that usually, so it's, if I remember correctly, there was like so in the dogfighting of the fighter jet, I think like the F-86, and if you compare F-86 and MiG fighter jet, then people think that the MiG fighter is usually like better like machine, but kill ratio like the kill ratio of the F86 actually outperforms the MIG jet. So this guy Boyd found that actually when you need to decide an iteration, so you need to when you need to so how can I say? Let's just it doesn't need to be that long, but the point, the punchline here is that usually the F86 is usually MIG is better system, has a better jet. But the one thing that F86 outperforms MIG is that the operation, right? Operation is they have a hydraulic system, so actually it was easier to adapt the strategy of the pilot. Other than that, for example, the speed and everything is worse than the MIG. But actually, those speed of iteration, how fast you act actually beats at the end how well you act, right? So usually his argument was that speed of iteration beats quality of iteration at the end, right? So this actually gives a lot of food for thought for us. So if we think about the machine learning lifecycle, right? We define a problem, we collect data, and carry out analysis, right? We model and we deploy. That's it, right? Very linear, right? But actually, I mean, many of you know, as many of you knows, this is not a linear process, right? It involves lots of iteration. So even after you define the problem at the data collection and analysis phase, if something wrong, you need to go back and define the problem again, right? And when you model, right, you can find out that actually, okay, this is wrong data to solve the problem, then you need to go back, right? And when you deploy, something may be wrong, right? Then you need to model again. So actually, it involves lots of iteration. It's not a linear process. So which means that if you think about Boyd, iteration law, then the speed of iteration is very important here, right? So especially there's a deep disconnect between the machine learning modeling and deploying in production, right? So it should be the two, I would say that to get a better result in the AI model deployment, we somehow we need to make this iteration process fast. Questions? Okay. So another thing is that if you think about I think when we think about solving a problem with machine learning, I think we usually think about the modeling, right? How can I come up with our architecture? How can we train? How can we separate the train and validation data, right? So we usually think about the modeling, right? Which is the fun part. But actually, if you want to actually deploy this model or connect this model to an actual application, there are actually lots of things to think about. So for example, how should we collect the data, right? How do we verify the data, whether it's correct? How will we feature engineer to get our better result with our model, right? How can we manage our metadata, right? And also if you think about deploying, then okay, we need to carry out the test. You need to manage the resource. We need to analyze the model, process management, and also we need to automate lots of process and we need to like manage the configuration, serving infrastructure, monitoring. So lots of things to think about. So there are actually like lots of things involved if you want to deploy your ML code to do an actual thing, right? So this is where comes where the concept of an MLOps comes in. So usually what we want is we develop a machine learning code, and we want a like seamless integration from this development of the machine learning model to the actual operation, right? And when there is no MLOps, and I will say that this is like something that this structure is something you first think about when we want to like integrate our machine learning model to some the applications or service, right? So I took this diagram from this white paper written by Google Cloud. So the title of the white paper is like the MLOps, continuous delivery and automation pipelines in machine learning. I highly recommend for you guys to read this document. So basically it says when there's no MLOps, this is what people usually do. And which is that, okay, here is machine learning development, basically. Here is the development on the left side, and here is the operation on the right side. So what we usually do is you just like hand the data offline to the modeler, the CSV, like database, right? XLS file to the modeler. And they come up with a trained model, right? They open up their Jupyter notebook and run the model, train the model, and just hand out this trained model to the operation, and operation like somehow connect, right, that model to the operation service. Well, makes lots of sense, right? Very cool, but it has a like inherent problem, which is that in the production, like that one thing is like in the production, data will be fed into the model, right? And we found that the integrity of the data, to maintain the integrity of the data is very difficult, which means that, okay, how can we ensure that the offline data you submit it to the modeler and the data in the production are like same format, like same columns, for example, right? And because like the machine learning models usually performance of the machine learning model degrades over time, right? So when you need to retrain the model, you need to extract the offline the data and give it to the modeler, and you ask them to train the model again, and you come up you connect the model to the service, right? But another problem in this structure is that you cannot ensure that, okay, okay, this model runs well in the machine learning engineers environment. I would say the development environment, right? He carefully come up with the required package. He carefully make the environment to run the model, but it is also like very difficult to ensure that the trained model will also run perfectly in the operation environment, right? Because it may have different, for example, like Python version, it may have different package versions, etc. So this actually doesn't work very well, or at least it doesn't work efficient enough, right? for for an actual operation. So yeah, this is just anecdotal thing. So the level 1 MLOps is usually like this. There's like the two important point in here is that one thing is that there should be a single source of the data, which means they call it the feature. Usually it is called the feature store. So this feature store is a single source of the data, right? And from this single source, you need to extract the data for the model development, and you need to feed the data for the actual service. And also you need to use the data from this feature store to train your model. Okay, so this is one important part. So there should be a single source for the model development and model retraining and model serving work, right? That's first important point in this structure. So let's before I say the second important point, let's just follow through the structure, right? So okay, this is ML part, the model development part, and this is the operation part, right? So the modeler create a model, but instead of handing over the trained model, modeler actually pass the source code that can train the model to the operation. Okay, and it is like this process, right? So it is usually called a pipeline. Okay, so the operation take that pipeline and run the pipeline by themselves to come up with a trained model here. Okay, and use that trained model. They carry out the prediction service. Okay, so as I lined out, the second very important change compared to the level 0 MLOps is that now the machine learning engineers or data scientists needs to provide the pipeline, which is just like source code that can train a model. Okay, so not just like train the model itself, but the pipeline. Okay, so those two things. So if I review that, single source of the data and model training pipeline instead of the trained model itself. Those two things will comprise the level 1 MLOps. Okay, so also like it makes lots of sense, right? So, but if you think about it, this may be just like if you think about it, which means that so okay, let's suppose that the machine learning, the data scientists come up with like some source code, right? Training pipeline. Then how can you ensure that this training pipeline will run okay in the operation environment, right? It's the same problem as before, and you can't, right? So the level 2 MLOps actually add additional tests, okay, here. So, okay, when you submit your training pipeline to the operation from the machine learning part, then you need to set up an automatic test to check that it will actually run in the operation environment. Okay, so it also makes sense, right? So, okay, makes lots of sense. So what we did is we actually wanted to to set up this environment for our data scientists and project team. Okay, so But this also has a problem. And I think like this machine learning operation, I have like background in data scientist as you see in my introduction. So it has like the very critical problems, several critical problems if you want to actually implement this like level 2 MLOps. Most critical one is that it actually, if you think about it, it actually imposes quite large burden to the data scientists, right? Because like previously, data scientists just need to come up with a trained model, right? If you think about like the MLOps level 0, right? But suddenly you need to, the data scientists need to come up with a training pipeline, which is like reproducible, well-defined, and production quality software, right? And what I found in my career was actually it's not really very easy. Okay, so there are some guys that actually are good at the software engineering and data science, but not everyone are very good at both, I would say. So I think the reason could be like their thought process could be a little bit different. So if you think about like the software engineering, usually it's like there's usually like well-defined spec. There is a like well-defined spec, and usually software engineers usually incrementally implement their software to like reach to satisfy the specification, right? But for data scientists, like to reach some like accuracy like target, for example, cannot be attained by just incrementally improving or incrementally like implementing the software, right? You need to come up with lots of explorations, right? And test visualizations. So any questions? Oh, do you guys have any questions so far? How can what should I do if someone raised hand?
Dr. Shim, they can post their questions to the chat.
Oh, okay.
A question, so you can read their questions to the chat or to Q&A.
Okay, I see.
And I can read the questions at the end of the session. If you like, cool. You can go over the questions at the end.
Okay, cool. Okay, so just let me continue. And so this like this kind of converge. So usually data scientists usually use like Jupyter Notebook or other some the exploratory data analysis codes, right? But those codes need to be converted to the production level code. This was actually not very easy. And also like the this MLOps is as we find out, it has to have like some iterative components, right? Otherwise it doesn't work from our experience, right? For example, this like machine learning training pipeline might not work when deployed, right? They need to be debugged. But in the original organization, then there's no no arrows from the deployed pipeline to the model development, because this pipeline also needs to be debugged, right? So we also need this direction of the flow. And also, if you can come up with a perfect pipeline that can work in the operation environment, also like this level 2 MLOps works very well. But to come up with such a pipeline, then actually you need to be able to deploy the models, and you should be able to check the pipelines whether it runs well in the operation environment while you develop the model. Otherwise, the speed of this iteration gets too slow. This happened to us. So somehow during the development, you need to be able to check your code that it will be actually can be run flawlessly in the operation environment. Okay. So we had this kind of problem, and what we come up with is that, okay, something we wanted is that, okay, we need to like something like this. Okay, we wanted to preserve the model development environment, right? We didn't want to change the workflow of the data science that much, okay? But still, we want to be able to convert the data scientists like experimental code to the operation code. Okay, so this is not very easy to. Okay, so actually we our approach was that we come up with like a Jupyter extension, Jupyter notebook extension called the Link, and we actually solved most of these problems. So let me just go here. So I think I can show. It's basically the idea is that we want to like overcome or supplement the weak point of the Jupyter notebook in these areas. Okay, so it was like difficult to reproduce, difficult to version control, difficult to collaboration, difficult to collaboration between the deployment and development. Although it is like really good tool for the data scientist due to it, thanks to its flexibility, right? So what we did is we actually like created a create a like extension that can actually create a pipeline in the JupyterLab. I think I can show you a quick demo of this. I opened the. Can you see my screen? Can you see my screen here?
Yes, we can.
Okay. So, okay. Okay. So, okay, this is Jupyter Notebook with Link extension. So we installed the extension called Link. So let me just give you a walkthrough example to how to what I mean by creating pipeline within the Jupyter Notebook. Okay, so this is a like sample code that I made that I like prepared for the demonstration. Okay, so this is very easy example. So this is just like just creating and run a training and run a classification model for the iris data. Okay, so iris data is like I think most of the people here will know, but would know. But this is like the data is like the size and shape of the petal of an iris. Like there are like I think 4 categories of the iris, and the problem is that can you classify the iris according to those features? Okay, so usually I load the data, right, and then here's data, right? You can just show, and usually you create a data frame. You split the data to train set and valid set. You make data loaders by batch to train the model, and you need to define the model right? And instantiate the model, and you come with a logger, and you train the model, and that's it, right? So it's very happy. But the thing is, like, if you think about it, those cells, if you write something in the Jupyter notebook, it needs to be linear. Actually, it's not linear, right? For example, like this load iris data and creating a model is actually are irrelevant until you combine them to train the model, right? So we actually add so there are Jupyter cells, right? And what we can do with the link extension is that you can add the cell to the pipeline, which means you just because many of us actually explains the role of the cell using this markdown. You just like us type the explanation of the cell as in for uncomponent name, and just click this, and this cell was added to the pipeline. Okay, and just pick another cell. You need to create the data frame from the data loaded from the SciPy. So you also type something like create data frame, and just give me a moment. Oh, just a second. Let me just refresh. Sorry about that. So you just add another cell, but at this time, you just specify its like parent. Okay. Then on the left, you can see that actually the create data frame is actually comes after the load iris data. Okay. And you keep doing that to, to construct the entire pipeline, which I already made here. So let's save this. So what I did is actually I just created a pipeline in the same way, and you can see that it's actually logical flow like this. Okay, so it actually it has like 3 branches basically, right? It's data loading and prepare data loaders here, like define and instantiate the machine learning model here, and define the loggers to observe the progress of the training. Okay, and here just combine those 3 branches for the training, right? And because when we specify, then we exactly know what needs to be computed first, right? And what later. So you can just run like plain Jupyter notebook. You can just run the cell here. I'll just press Shift Enter here, and it automatically figure out the dependency, right? And then runs the cell in the order you specified. Okay, so and for the cells in this pipeline has a separate memory. So I think many of you have an experience that if you tinker with the Jupyter notebook, then it is very easy to corrupt the memory, right? You may accidentally to change the data or change the object. They change the Python object, but this doesn't happen because it has a separate memory. And it always can give you the deterministic output, okay? And also, but still the like real power of the Jupyter notebook is you need to be able to take a look at the inside of the object, for example, right? This is also still supported because the object created at each step actually will be copied back to the plain Jupyter memory. Okay, so in here, there's like the max epoch is 10, right? So you can take a look at the max epoch like this. It is copied to the like plain Jupyter memory. But if you like, for example, like set the max epoch to something else, then it will not affect the operation of the execution of this pipeline. So you can naturally get like a well-defined program that can be used in the operation if you can export it, right? So, and also you have a like small disk icon here, right? This is actually, you can set up a disk cache. So when something was run once, you don't need to run it again. So for example, I already trained this model with epoch of 10, right? So if I run again, it doesn't actually run. It just pull the result from the cache, okay? And you can share the cache as well, because you can export the cache as a file, because all of the cell output was serialized. So yeah. So like this. So when something's go south and you need to restart the kernel, you can still retain your like intermediate output. Okay. And right. And also the point was that it actually needs to be connected to the operation part, right? So actually this pipeline, when run, after running, you can export the pipeline, for example, as a like kubeflow pipeline. Okay, like YAML file. Can you just export, for example? Then you can just like upload this YAML file to like many MLOps system. For example, here is like kubeflow, so that you can, you know, you can run the pipeline without Jupyter Notebook, but just in the MLOps system. Okay. So also another thing was like that for a well-defined program or production level program, the version control is very important, right? But also, as many of you knows that in the Jupyter Notebook, it's like actually like one big JSON file, right? So it's very cumbersome for version control. So we actually developed another module for the version control. Okay. So let's say that, let's just like remove this. If I change some output, what I will do is, okay, perhaps that I'll add another cell. Yeah, so I add another cell. And probably like train a little bit more after my first train model, right? So let me say we train, and I'll just put after the train model. Then I updated this pipeline, okay? Then, and I maybe want to change the number of epoch here to different numbers, right? And I save. Then the previous one was actually like checked in a GitHub, but I changed some code and added some, the pipeline component, right? Then if I go to this Git extension, and you can see the difference visualized like this, okay? So it actually shows that what components were added. This was added, right? For example, here. And what part of the code will change it like this, okay? So actually you can, with this, and it actually has like a merge driver as well to support the Git. So you can actually do the version control better with this JupyterLab Git, like with Link, thanks to the pipeline structure, okay? So, right, okay, so this is the link, and let me go back to my presentation. So yeah, so this is like free of charge. You can try that. We actually did like lots of positive feedback within our data science team, which I'll tell you about a little bit more. So what you do is just like go to the product web page and you can download it, or you can install it with a PIP, and you just like you can easily obtain a product key. Basically, you just like provide your email and you will get a like free product key. Documentation. It's an English version is a little bit awkward still, but we are improving it. So we have a documentation for how to install, how to use, and the examples for the pipeline. And also like there are two guys actually made a review for this extension. So one guy is called Vu, and another guy called Sunny, Vivan Chandra, actually made a good review to how to like use the link for a data scientist. Okay, so the actual application is like the okay. Let me talk a little bit about the machine learning. So machine learning usually, as I said, that we want to apply the machine learning or artificial intelligence or data science to the manufacturing. So we have a lot of projects. We carry out lots of projects. For example, that this is very classic problem. So we want to improve the chip placement of electronics with a reinforcement learning. So we want to come up with a model that can actually predict the breakdown of a robot arm here. So we want to we are developing motion planning and distribution multi-robots within the factory to satisfy the cycle time. We are developing the machine learning based like the energy. This is basically like just like the air conditioner and heater within the electronic vehicle. Okay, we want to optimize the temperature control with reinforcement learning. We have the model to predict solar power generation. We develop a model to predict again like the equipment failure for the semiconductor manufacturing, something like this. So we have a lot of manufacturing projects going on, and actually the deployment environment are all different in this project. But after we have the link, and we have also the MLOps platform called the Runway, we actually could cut down the development process dramatically. Okay, so yeah, so basically the Macarox is a startup. It's 5 years old. We are in the Series B stage, but this is a little bit outdated. We have 80 people in Korea and Silicon Valley. Yeah, so we were chosen as top 10 pioneer companies. Yeah, so yeah, I think that's it. So I think that to summarize, I think that what we at the end, as a data scientist, at the end, I think we want to all of us want to see that actually our model goes in production, right, and is utilized as a part of service, right, and contribute to the actual value of the service, right? But for that, on top of the core like machine learning like capability, we actually have a lot. There are actually lots of things that need to be done for the successful operations and for successful like improvement. Okay, so you need both of those like core ML capability and like this MLOps environment for successful AI solutions. Okay, and another argument of mine is that I think like what we found is like current existing machine learning operation system, MLOps system, was actually like impose quite heavy burden for the data scientists. So we actually come up with some application that can, for the data scientist, for the for the model developer, to create the pipeline and to connect to the operations like much more easily. Okay, and it's free of charge, so you may want to try that. Okay, so I think that actually concludes my talk here. So yeah, any question will be appreciated here.
So Dr. Sangwoo Shim, thank you so much for the presentation. It's very nice to see you again, by the way. So there are some questions here. I don't know if you can see them, but I think the one question is this notebook that you just used for this iris dataset, is it going to be available? So
yes, actually, yes. Let me just like copy and paste these links. Yeah, they are available if you just down. Yeah. Let me just post this first. Chat.
Thank you.
Right, and the iris, this notebook is actually, I have it in GitHub, I think. Actually, the Git book link, actually, it has like the exactly same examples I showed. Yeah, so yeah, you can take a look at them.
Okay. Thank you. So there are some questions. So some earlier questions like I don't know. Let me see. I don't want to miss any of the questions, but somebody asked if you could tell more about the feature store. I think during the presentation the question was posted. And have or use any standardized tests that the code should conform to. So that was coming from another person. So these were questions related to the earlier part of the presentation. Maybe we can focus on the presentations related to the link tool.
I think this part, right? Tests. Yeah. So I would say that this is like this is really case by case. It's very difficult. So and it's really time consuming to come up with this kind of test. Okay, so what we are developing for the link and the runway, our ML system, is that we actually instead of carrying out this test, we actually what we did is it's a little bit the approach is a little bit different. So we we actually capture the development environment here, and we can export that environment entirely as a Docker image to run this pipeline in the production. So we actually bypass the necessity of this. But if you go back to your original question, I would say that the standardized tests are very difficult to come up with. So I think it usually varies from project to project. You just need to come up with a case by case.
Yeah. So as you were giving the presentation, I was thinking about value proposition of this tool. So this addition to Jupyter Notebook. So I can understand someone who's learning machine learning after a while, as gets some experience, can definitely use. Somebody teaching machine learning can definitely use. But I'm more curious about the value for practitioners. Somebody who's really professionally working in the field. Very hard to show, demonstrate the value with a case study here. But can you give maybe one or two more sentences about the value for the practitioner?
Practitioners, right?
Yeah.
I think like personally, actually starting to use this tool myself. And for practitioner, I think the most important thing, and I think the important feature, is that you can actually now the version control your Jupyter Notebook very easily, right? Because it was like very tricky to do version control, like for example Git. It was really difficult to see the difference between those notebooks, right? Because there's no specification of the logic flow in the Jupyter Notebook, right? So original author may know how logic changed, like along the changes of the Jupyter Notebook, but for the collaboration or for the like history tracking, you need to come up with how your logic changes. Then, as I could show that this like the Git support, especially for the practitioner, will be very useful. And another thing is that actually, like the to bridge the gap between the development and deployment. So I think that more than open, usually like the practitioners usually like required to come up with some like working, like well-defined production level code for the actual production, not just Jupyter Notebook itself, right? In this case, we have like we can export the pipeline to the, for example, like Kubeflow. We can actually export the pipeline to like the Python script, and also like we will be able to export the Jupyter Notebook with our like pipeline engine itself. It's in development though. So I think those two. So one thing is like Git support, and the other thing could be something like the bridge between the development deployment gap.
Are there any plans for extending this to outside Jupyter Notebook, say other code development environments?
Oh, that's actually a really good point. We are just thinking about like the VS Code. The VS Code also is like, but there's still VS Code is like Jupyter Notebook engine, right? So we have a plan to build on top of those Jupyter Notebook VS Code Jupyter Notebook engine. Yeah, it's a really good point. Yeah, not like
Okay, so
planned yet.
Thank you. So, I mean, I don't know if you can see the questions. So there are questions.
Oh, I can. Yeah, right. Okay. So yeah, the notebook you can download and apply inspection. So if you take a look at the link I showed, that there's like documentation for link, right? If you take a look at the chat window, then there will be you can find the exact same notebook. And also, actually, let me give you another example. Actually, we created a large number of examples here, I think. Link example. So we have a few examples here.
Perfect.
And it's open. So let me just give you the link of this. Yeah, so we created like this is usually like well-known toy problems, but still there are like many examples for the link extensions. Okay, and then is Link like a workflow for Jupyter Notebook? Yes, it is. Yeah, and right, have the link to this. Yes, you can find the notebook, and I think that's pretty much it. Let me Q&A.
So this tool is open source.
Oh yeah, it's free of charge at this point, and I think it will be free of charge. And we are thinking about like the like separate this extension like by parts, and some parts will be open source. For example, like the main engine and the pipeline specification will be open source, but probably like some of the front end development could stay in commercial. But we are working on this. But I mean, we don't have the link itself is for it will be free of charge. And can machine learning and then I make the programmers obsolete? I don't know, but I think not yet. Yeah, because what you're thinking, what you're saying is like the strong artificial intelligence, like, but I think we have a long way to go to make this happen. But probably some of the work, some of the job we are working on could be like substitute, but not entirely yet. Yeah, so we still need to learn and improve our skills. Yeah.
We have 3 minutes left. So there is one question on, is this going to work on Colab as well?
Not yet.
And there's one question on your download page. What is the difference between Python package and desktop application?
Oh, desktop application is that actually we can Python package is just like a Python. You can install using pip to your existing Python environment. But the desktop package is just like it wraps around a Python environment, so you can run it as a desktop application. And also, actually, you guys mentioned Colab. Actually, we open you can run the link in the binder. So without my binder, right? Where is it? You can actually run it without installation. You can run the Jupyter Notebook with the link extension in the my binder. Let me just copy this link and chat. Yeah, you can try this. Try it here. Just click this and you can experience the link without installing anything.
All right, so I think our time is up. Dr. Sangwoo Shim, thank you so much for this presentation. I enjoyed myself this presentation listening to you. I learned a lot. So thank you very much. And thank you, listeners, audience. Thank you so much for participating. Please let us know, post your reviews, let us know about this presentation. So we would like to bring distinguished speakers as Dr. Shim, so that we are going to benefit from their experience and their new products. Thank you very much, and we'll see you in our next meeting. Thank you. Bye.
Thank you. Let's keep in touch.
Bye.
Bye.